All right, we learned how Anton van Leeuwenhoek did the. God.
Come on, man, get it right. Van Leeuwenhoek.
Yesterday we heard about Anton van Lederhosen. No,
His name is Van Leeuwenhoek.
we learned about Anton van Linoleum. I'm never gonna get it right.
All right. Hey now. Mr. Kovacs class. It's Mr. Kovacs class. You might learn a ton. It's Mr. Kovacs class.
It's interesting too.
It's Mr. Kovacs class.
And he's super cool.
It's Mr. Kovacs class.
All right, I'm just gonna refer to him as AVL. Because you know what? When you're super cool, you can go by initials. AVL. AVL. So today I'm going to show you, we're going to learn how to be like little AVLs. And I'm going to show you how to use a microscope. Now, if you recall that AVL, Van Leeuwenhoek,
Van Leeuwenhoek?
use what's called a simple microscope, right? Or a magnifying glass. Look at it, it makes things look bigger. Not much bigger, but bigger, right? I think this microscope magnifies things 3 times. There's Van Leeuwenhoek. What we're going to use is what's called a compound microscope. And what makes a compound microscope compound is it uses not 1, but 2 lenses at the same time, which will make things look like they magnify each other. But the problem is, it's harder to focus now, right? And there's some other things. So I'll show you what we call this. We call this a compound 2-lens microscope. And I'll show you how to use one today. And then we'll practice for a few days. If you're virtual, you're going to practice at home, learning the parts and what they do. And if you're here, you're going to actually get your hands on a microscope. Although COVID protocols in effect, we're going to be doing a lot of cleaning. All right, so here's one of our microscopes. This one's called the Wildcat.
Yeah.
I don't know, I give them all names. Anyway, okay, if you think of it, Van Leeuwenhoek used just 1 lens, right? He looked at 1 lens. Compound microscopes have 2 lenses, one that you look through right at the very top, and then the second one that you look through down by the bottom here. Okay, and so what's cool about these microscopes here is you can change the magnification of the second lens. This guy's always like 10 times real life. But I think on our microscopes we've got choices. The short stubby one is 4 times, the medium size is 10 times, and the big one is 40 times. So when you're looking at something, it's a combination of those 2 lenses. You multiply 10 times, in this case 40 times real life. 10 times 10, 100 times. And if I get the big long one in place, 10 times 40 is carry 2, 5, 2, square of the square root of the cosine of the 40 times 10. Oh yeah, 400 times. Let's see, what do you really, really need to know? So, just like Van Leeuwenhoek's microscopes, we have a place to put our specimen. We call that the stage. Stage. Okay? Our microscopes have little clips to hold things in place on the stage. I find they just get in my way. Okay? Like Van Leeuwenhoek's microscope, there's a knob here. See this knob? And if you notice what it does, it's probably hard for you to see from your point of view, but it moves the stage. It's kind of like, instead of moving the lens, we leave the lens and we move the stage. All right, what else has it got on? Of course, in order to see the specimen, we need light. So these guys have light bulbs. In the old days, they'd use like a candle and a mirror to flip. Can I get that? Ooh, it works. Yay. What else you need to know? This little screw in here, this is the stage stop. Okay, so that determines how far up or down the stage can go. And oh yeah, there's a little knob here. This big one that moves the stage up and down a lot is called the coarse adjustment. This little one is called the fine. It does the exact same thing. It's just called the fine adjustment because it does so finely. One of the rules of thumb of microscope is whenever you start using it or whenever you finish using the microscope, you always click that, there it is, the smallest lens in place over the stage. Let's look at a specimen. And then in class today, if you're in class today, you're gonna look at a specimen and see if you can do this. And then if you're not in class today, on Thursday, you'll do it in class. All right, so here's my microscope. You can see I've attached a camera to the eyepiece lens. I see it on my computer screen, and I do that because it's hard to see. That's the hardest thing about microscope, is seeing what the other person sees. And then first specimen we're gonna look for Amy. So the first thing you notice is, this is gonna be what we call a prepared specimen. It says amoeba. WM means whole mount. And then Amy's in this, see that circle? They're in there. And actually, if you really look carefully, you can just make out a few colorful specks. Those are Amy's. She's not alive in this specimen, and she's been stained so you can see her. Otherwise, she'd be see-through. We call this piece of glass with the specimen on it is called the slide. And the slide always goes on the stage. And you want to put the slide on the stage in such a way so that the light comes through the stage, through the specimen of the slide, through the objective lens, and finally through the eyepiece lens so you can see it. Okay? Always want to do that. Right, so I got slide, specimen is in that little circle. Little circle goes over the, right? And you notice I have the smallest lens in place. All right, to find my specimen, the first thing you do is you start with the smallest lens in place, and you move the stage so it's as close to the lens as you can get. Like, I can't get it up anymore, any closer. As close to that as I can get it. And then you slowly move it away until things come into focus. All right, that's how you do. Now I'm going to show you what I'm looking at so that you can, there you go. All right, so this is what it would look like if I was looking at it. I'm looking into, right, this funny looking screen is what I see. I slowly move the stage until, whoa, things come into focus. And oh look, there they are. Amy's. There's an Amy with the nucleus. There's pseudopods. Now this is at 4 times 10 to the 40. If I want to see Amy bigger, if I want to see her bigger, all I have to do is change the lenses. I got Amy right in the middle. All right. So you can see I've got the small lens on. I'm going to turn so the medium-sized lens is on. All right, a medium-sized lens. And whoa, there she is, a little bit bigger. Now, you know she's a little blurry, so that's why I can use the fine adjustment, the little knob. The fine adjustment to like dial in the focus. And if I wanted to see her super mega sized, I could even do one more, the biggest lens. The biggest lens. Now, when you're in the big lens, you pretty much only want to use the fine adjustment in the biggest lens. And the biggest lens, I mean, look, it gets so close. All right, so when you're in class, you're gonna try to find an Amy, you're gonna try to find a Perry, you're gonna try to find a Eugene. That's gonna be the 3 things I try to find in class. So 3 different specimens. So the sequence is, of course, slide of the specimen on the stage, lowest power lens in place, coarse adjustment knob turned so that the specimen is closest as you can get to the stage. Slowly turn the knob until the image comes into view. Then you can change magnifications just by turning the knob. All right? And of course, today, if you're in class because of COVID, you're gonna be wearing gloves while you handle the microscopes. And then when we're done with the microscopes, we're gonna give everything a thorough wash down, clean up, disinfecting. Okay, so that's really important because, you know, a lot of people, when handling these, we wanna make sure that they are clean. All right, let's try to find an Amy, a Perry, and a Eugene.